Hi, I'm Pat Kelly. Okay, did you catch the directions to this problem? We're supposed to find the sum of the infinite series. Notice the upper limit of that index is infinity. That means we have to add this expression as k goes from 1 to infinity, like the end of time type of expression. So that sounds like a lot of work. The type of problem you might leave out on your desk and go to bed and see if the goblins solve it for you in the middle of the night. I'm not going to trust that, so let's figure out how to do this. What you want to do with this type of problem is, you of course, I'm playing around, you're not going to go to infinity. You don't have time for that. So look for a pattern. What you are going to do is write out the first few terms until you see the pattern. And then we just speculate, not even speculation like we're unsure, but we extrapolate and get that final answer. You'll see with this one. So let's write out those first few terms. When k is 1, 7 is still the coefficient there, and then 1/10 is going to be raised to the 1 power, plus from the sigma sign, 7 parentheses 1/10, and now to the 2 power, plus 7 1/10 to the 3 power. Maybe I'll try one more. 7, sloppy, 1/10 to the 4th power. All right, that's my 7, the same as in all the other terms. There, okay. All right, let's see what each of those terms looks like if we evaluate it a little bit. Do some arithmetic. And this goes against my grain here, but I am actually going to go to decimals right away. That's because it's going to be easier to see the pattern. And that's common for this type of expression, because 1/10 as a decimal, that's just 0.1. And I'm going to multiply by 7, so you can write that first term as 0.7. And similarly, with the next few terms, as a decimal, 1/10 but squared, that's 1/100th, but then multiply by 7, and this second guy is just going to be a 0.07, see? Plus, third term, the 1/10 to the 3 power, that's 1/1000th, but then multiply by 7, that's just going to give me a 0.007. And if I go one more with that fourth term I have, see why the decimals are showing me a little bit of a pattern? I do want to suggest it's plus dot dot dot, because it does go forever. In fact, if you'll allow me to come up here, that really again is plus dot dot dot, okay? All right, let's go down to the next step and recognize that if I have 0.7 plus 0.07 plus 0.007 and forever, we're really looking at 0.77777 forever, a repeating 7, right? And that's great that I've recognized the pattern now, because this exactly equals 7/9. All right? You don't believe me on that. If you're not getting that fraction as quickly as I did, you can grab a calculator and do 7 divided by 9, and your display will be this exact repeating 7 expression. Okay? But you want to look for that type of pattern in these problems. You are not going to add to infinity. Add the first few, look for the pattern. Okay? Good luck. Try some on your own.